All right. Hello, everyone. We're gonna give everyone a few minutes to show up, a few more seconds, and then we'll get started. Excellent. Okay. Well, hi, everybody. Welcome. I'm Mike. I'm one of the co-founders, and I'm the CEO of Tecton. Excited to have you here. We've got a lot to talk about today. There's some really cool new stuff in Tecton 1.0, and we want to tell you all about it because we think it's going to be very helpful for you. And by the way, along the way, please add questions to the chat. I'll try to check that, but we've got other folks who can answer questions along the way. And yeah, let's get started. Okay, so I thought it would be quite interesting for us to just do a quick recap here, right? Just from Tecton's perspective, we started building we worked on Michelangelo at Uber back in 2017. We actually started in 2015, and that was one of the first platforms that was really successful at making an organization scale with machine learning and AI. And there we developed the first feature store. And that was very important in enabling this kind of like Cambrian explosion of machine learning at a company. And when we saw the quality of change that enabled within for a variety of different use cases at Uber, we understood the importance to the broader industry. And so we started Tecton. And in 2020, we launched the first version of Tecton, which is the industry's first feature platform. So it was all about how do we help different teams with the end-to-end data problems that they face in building and productionizing AI applications. And since then, the past couple of years, we've been working with all kinds of organizations and improving the platform in terms of its core capabilities, its efficiency, its performance, and most importantly, its reliability and core trust, its ability to be used for mission critical use cases. And I'm proud to say that today, Tecton powers AI products for some of the most important companies on the internet. There's a ton of different use cases that Tecton's being used for, from fraud detection to credit decisioning to recommendations to dynamic pricing, all kinds of things, from stuff that's on Fortune 100 companies' core homepage to startup companies, maybe more minor use cases. So Tecton is used in a very versatile way. And let's talk just briefly about like what is the problem, right? Like the goal is for us to have reliable and accurate production AI systems. The core challenge that we've seen so many folks have is that getting there is just a really intense battle of data engineering and operational debt. And it's just really complicated. And it kind of looks like this, right? There's a lot of stuff to solve. I'm building a production AI application. I have a variety of different data sources I have to integrate with and maybe and ingest and transform in some way. I also have to manage the storage of that data across various data sources, various storage layers for online retrieval and for offline usage. Offline, it needs time travel for me to create a training data set. And online, I need to look up things really quickly. I need to be able to serve these features with high reliability and freshness and speed. And so there's just like a lot of stuff going on here. It's a big mess of data engineering, the backfill I might have to do, et cetera. But also, there's a variety of different personas that tend to be involved here. There's data engineering, data scientists, MLOps. They all have to find a way to work together to make this whole system work as a reliable production application. And so when you go to these teams and you see the challenges that they have, what we've observed is a lot of these AI projects, more than 80% of the time is spent on wrangling these data issues, just getting this stuff up and running once. And this is really a doubly challenging problem because you have to do this and get this right, not just for every model that you're building, but for every feature within every model. Timelines are slow. They're measured in, typically a lot of our larger organizations measure these things in months, which is way too slow. This should be in in hours, basically. And when companies are solving this themselves, they tend to underestimate some parts of the problem and actually incur increasing tech debt as they go along. And this is a really big trend. We've seen people kind of spiraling in tech debt. And I can't even tell you, I heard one company the other day tell me, hey, I've got 3 models in production. I'm scared to put number 4 in production because of the added burden to us. And all of this stuff, you want it to operate correctly, but it's really hard to validate and to monitor. And then when something goes wrong, it's really hard to debug. So how do we fix this, right? So we've started Tecton with some principles for AI engineering success here. The first is we've called it managed features as code, and it's really about taking AI and ML out of the laboratory and helping it be treated as a production process, treating it much more like standard software engineering. So that's one of the themes that we have throughout Tecton. The other is about unifying development of production environments. It's not about those being literally the same environment, but it's more about ensuring that you don't have the, well, it works on my machine problem, and you remove the throwing it over the wall problem for someone else to implement in another environment, which slows things down dramatically. The third is about really leaning into collaboration. Most models at larger organizations have multiple people contributing to them, whether that's different people building different features or reusing features from another model, or people reusing the same features for multiple versions of the same model. So it's really important to enable teams to collaborate really quickly within a project. And then finally, under the hood, as we looked at a second ago, there's all kinds of infrastructure that needs to be provisioned and orchestrated and configured and all of that. And there's, on a per use case basis, there's all kinds of different performance needs that need to be considered and cost needs that need to be considered. And it's quite complex. And so a principle for Tecton is to just provide automated performance out of the box. So that means performance, efficiency, and reliability should come out of the box and be as simple as possible for teams to get something that's really world-class going without needing to be performance experts. So at Tecton, we built a whole new approach here. And we started with the feature engineering workflow. We made it really easy with our declarative workflow for someone to be able to, or declarative framework for a data scientist and ML engineer to write a simple Python file that describes a specific data asset that's needed for their models in production. This is a feature, and we're expanding from there. But from that simple file, what Tecton does is it builds automated data pipelines that are continuously updating. So we provision the infrastructure, configure it, and orchestrate it so it's continuously running and turning raw data into refined feature signals that are used to power models both in training time, so this is an offline store, both in training time for point-in-time correct historical data, or online for real-time retrieval from the model at inference time. And this needs to be powered with robust infrastructure, super reliable. It needs to operate. It needs to be very fresh and operate at scale. Everything that you would need to trust this to power your core AI on your homepage. And we've come a long way with that, right? We've enabled, through all parts of the AI workflow, we can go through them. We've really enabled a kind of highly streamlined workflow. So within experimentation, it's all about how do we enable MLEs and data scientists to rapidly define and discover features as quickly as possible. How can they iterate really quickly? And then how can they, when they find something great, how can they productionize it really quickly? How can they go from idea to instantly this is available for an experiment online, or this is being used by my model in production? And then thirdly, we need to control and govern which data it can be used where, and collaborate and reuse features across use cases. And so it's been very important to support that and create a system of record for all of the data used in AI systems. And then finally, serving features at any freshness, any throughput, and any latency that's needed by the production application, and do that really simply without needing a huge team of engineers to support it. So this is what Tecton has delivered, and it's been going really great. We've been growing the number of use cases and AI products that we support over, this is a chart from the past 18 months, I think, and it's been growing. Our customers are adding more and more use cases every single day. And before we tell you about how we're expanding Tecton and the new capabilities we're adding to Tecton that are hopefully going to allow you to build more things in Tecton, let's hear from one of our customers as well.
Machine learning is critical for Coinbase. It's how we protect our users from fraud. It's also how we create an engaging and personalized experience on the app. And it's also how we're able to process different kinds of blockchain data. It started off entirely ad hoc, where people are just building these pipelines themselves. It's very manual, all kind of handcrafted. The reality is for Coinbase, we're going to have thousands of features, hundreds and hundreds of pipelines running at any given time to support machine learning. So if you look at a machine learning engineer and what they really want, they want to build models that deliver business value. What they really don't want is to be worrying about low-level infrastructure details, like whether or not something is streaming or batch or how much compute it's going to need. Tecton provides a framework to build features that abstracts away the data source you're working with, the aggregation you're running, these kinds of things, and lets you really focus on the actual feature you want, declare it, and then Tecton will help you generate training data and serve that feature in real time. The same person is able to develop the feature, generate training data with it, validate it. That same code ultimately becomes the production pipeline. And it's just one person that's able to build that all out. And with Tecton, we found it's much easier to build these batch and streaming pipelines, and we can focus more on the types of features specific to Coinbase, the types of models we're building, and basically move up a layer of abstraction. I'm definitely excited to see where Tecton goes. And I think there's a lot that can be done around computing embeddings, serving embeddings, as well as kind of getting real-time context into models.
Thank you very much, Joseph. Hi, everyone. I'm Kevin Stumpf. I'm Mike's co-founder, and I'm also our CTO. I'm super excited to tell you a little bit more about some of the major capabilities that we are launching with Tecton 1.0. So let's take a look at these 4 capabilities that you see here that bring feature engineering really to the next level. First one is remote dataset generation. And you just heard it from Joseph. Machine learning engineers, they do not want to have to deal with figuring out what the right provisioning of infrastructure should look like in order for anything to work. They just want the system to magically handle data pipelines, the generation of training data, generation of predictions without having to worry about the infrastructure. And I'm sure many of you in the audience, you've been there, you tried to generate a training data set or a batch prediction data set, and things just wouldn't work. Either the data generation job would just take forever, or maybe it would entirely blow up with nasty out-of-memory exceptions that you had to debug. And you had to fiddle around with the proper provisioning of, say, your Jupyter notebook that's hosted somewhere. Now, those days are gone with remote dataset generation in Tecton, which makes it possible to generate training datasets or batch prediction datasets of any size, in any environment, at any scale, as long as you can import our super thin Python SDK. And what this means for you is that you do not have to deal with out-of-memory exceptions anymore. You do not have to deal with setting up a local Spark context anymore. And you're also not bottlenecked anymore by your local laptop or by your Jupyter notebook, because this entire operation is fully parallelizable. And overall, and finally, it also generates data sets that are versioned and securely shareable between the different teams, so that once you've got a data set that you're happy with, you can easily share it with other teams. Cool. Besides data set generation, we've also made major strides in our high-scale aggregation engine. And we've introduced this concept called tiered tiered tiling, which makes it extremely easy to generate time window aggregations over any size, because I'm sure many of you faced the trade-off where you have to choose between really a time window length and performance. And the longer the time window, the worse the performance, the worse the read latency, and the higher the cost. And with our tiered tiling system, we've now made it possible that you do not have to face this trade-off anymore. Tecton now makes it possible to generate time window aggregations over any time window size with really unlimited event count, and it makes all of that possible with extremely low feature or really high feature freshness and low read latency. Cool, so those are high scale aggregations. Those typically make up about 70–80% of predictive machine learning models out there. But what we've seen recently become more and more important are ML model generated features, where we see customers who want to turn some unstructured data that they have into a signal, into a feature for their predictive ML model using another model that analyzes the content. And so you can imagine, for instance, maybe you have a predictive ML model that tries to predict which ones of my customers do I want to send a promo code to. And it may be quite useful for such an ML model to take a look at, well, how happy is this customer right now? What's really their sentiment? If I look at recent support messages I've received from them, or chat messages. And a use case like that is now trivial to implement in Tecton, because you can bring any arbitrary PyTorch model into Tecton, which can process both unstructured data like text or images, as well as structured data, and then make the output of those really inference calls available as features to your downstream ML applications. That's fully supported for batch inference today. And what's coming soon is also stream inference as well as real-time inference. And one particularly important type of model-generated ML features that we see all the time are embeddings. Embeddings are extremely powerful to turn unstructured data like text or images into signals for your downstream ML models. A very common use case out there, of course, recommendation systems, where maybe you want to embed your product descriptions or your product images, and then make those embeddings available in a vector database that you can then use to ultimately power your search ranking or your recommendation system application. Besides that, a really powerful use case for embeddings inference that I'm really excited about is where I've seen some companies out there use embeddings to look at events and behavior of customers. Like, how is a customer interacting with my website? How is a customer interacting with my mobile app? What are all the different events that are coming in? And then they have an embedding model ultimately generate signals from that your ML model can pick up on in a way that would just be harder to express with hand-engineered ML features. Those embeddings are, of course, continuously updated by Tecton, just the exact same way that all other ML features are continuously updated in Tecton. Besides that, our engineers have taken great care to ensure that the implementation is very, very cost efficient. Because these data pipelines ultimately can cost quite a lot of money. Awesome. So to recap, what's now possible with Tecton is that you can build more powerful and more cost-efficient features with Tecton. Remote dataset generation makes it super easy to generate training datasets, small or gigantic, from any environment without having to worry about local provisioning. High-scale aggregations make it trivial to have extremely fresh time window aggregations that can be as large as lifetime aggregations. And then model-generated features as well as embedding features allow you to turn your unstructured data into high-value signals for your models. And with that, I'll hand it back over to Mike.
Thank you. Okay, cool. So Kevin just told you about some of the new capabilities that are added that we're launching at Tecton to support predictive machine learning use cases primarily. And I want to talk about an opportunity to get more value out of AI. And one of the ways Tecton is supporting that as well. And I thought it would be interesting to take a step back and look at this market trend. There was recently a report from PwC that estimated that personalization, just personalization, is expected to add $5 trillion to global GDP by 2030. That's a really huge number. And that impact is going to come definitely not from small incremental improvements in personalization. It's going to come from some step function changes. That means we're going to be building applications that are qualitatively better and more personalized than anything we've had in the past. And personalization is just one use case. There's a number of use cases, but we'll dig into this as an example to motivate some of the additional changes that we're launching in Tecton that should make things a lot easier for you. So I think the first question, and then the core enabling question for personalization is, does the AI system that you're building actually know your users, right? That makes a really big difference in what the end experience is. So what do we mean by know your users? Well, if you've built a travel recommendation application, and when your customer or your user goes, hey, where should I travel over summer break? Your AI can show up in one of two ways. It can show up as almost like a stranger who doesn't really know the user. It's a travel expert, it's a travel agent, but it will say something very generic like, hey, just go to Paris. That's a popular spot, right? Or your AI can show up as someone that really knows your user. It's almost like a best friend level of understanding of your user. So you have both high expertise, you know a lot about the world and the destinations, but you also have high context, you know a lot about the user. And when that happens, we can provide really personalized recommendations. Hey, you said you loved that sailing trip last summer. Why not go check out the Rhodos Cup in Greece that's happening this year? That place is a very cool little town, and it's related to a lot of the things that you like. Then we can provide a much higher tier experience or a product experience if we can build much deeper personalization. But how do we get that? We need context. Context is what allows your AI to know your customers, right? To really understand the situation and reason about it. And that's the key problem setup that a lot of companies trying to figure out how to use AI to build amazing product experiences are encountering today, right? They have a bunch of data, whatever data sources they have in their data warehouse, in their event streams, may be available in the application live. And they need a way to provide the right data at the right time to their model so their model can have the right behavior and behave intelligently. But building context for LLMs is a data engineering headache. It's very similar to and analogous to the same problems we were just talking about with predictive machine learning, right? There's a bunch of things we have to do. First, we need to construct the context. This means we need to ingest that data, transform it, and stage it for serving and for delivery, right? And now it's not just features. We have a bunch of things. We got features, we have embeddings. Maybe we have candidates that are considered for a recommendation, come from a similarity search. And we can think of what each of these are. In this example, what's the user's preferences? What's trending right now? The embeddings might be like a dense representation of a user's profile. And the candidates are, for example, the different destinations to consider in a recommendation, right? And so there's a lot of data engineering that goes behind this to get all of this together. And it's all the same problems we just talked about and more. The second step is we don't have to only build the context, construct that context, but we also have to make it accessible to the model. We have to deliver it to the model so the model can retrieve the right information at the right time. And this is also an operational headache. This is a domain. This works in the production environment. It operates at inference time. This is where we have to scale infrastructure and monitor it for SLAs and all of that kind of stuff. And there's two different common types of ways where this data can be accessed. One is through standard prompt enrichment. This is where we're dynamically injecting context data into the LLM prompts at inference time. So we have, like, imagine a prompt template, and we're delivering in the right information into that prompt to effectively enrich the prompt and provide a lot more context so the model can make a better decision. But that's a little bit of a kind of a proactive data delivery to the LLM. But it's also a very valid use case for more agentic systems to determine that they need more information. And so they also may want to interact with a tools interface. That's where we provide LLMs with an API to query the right contextual data on demand at inference time. So they can come back and say, hey, actually, I need more information about the user's preferences because I'm not sure which thing to recommend. And that's a really nice new capability in that LLMs, and specifically agentic LLMs, unlock, as this ability to go back and forth and iterate on the reasoning until we find the perfect recommendation. When we get that right, then we can have a really good recommendation, right? That's how we can get to the, hey, the Rotos cup in Greece is perfect for you because, and we can also even describe the because, which is really nice. We can get this best friend level travel agent recommendation. And so how do we do all of this stuff? This is pretty challenging because it's both involves development time type of work, a development workflow, and the full productionization side of things. And this is exactly what Tecton solves. If you think about this, this is the exact same vision that Tecton has always been around for with respect to bridging the gap between your data and the AI systems that need access to the right data at the right times to power your customer experience. And Tecton here becomes a system that integrates all of the different data sources across the business and delivers it for usage across any type of AI application. Tecton becomes a little bit of a knowledge gateway for your models. And this is built on top of the same Tecton unified platform that we've been strengthening for some time now. You can use this platform to assemble, manage, and retrieve context. Plug into any of your common data sources and deliver that data, those embeddings, those features, any context to any type of AI models, whether it's predictive ML or generative AI or rules that are manually crafted rules and heuristics, right? And this is done with the same core components that have been so useful with Tecton up to this time. We've just been expanding them, right? So the core declarative framework that allows for a very software engineering type workflow for building AI applications is being expanded here. We're building on top of our unified compute that abstracts away a lot of the infrastructure details and makes it really easy to run compute in a simplified way for people building AI systems. There's a context registry, which is similar to the core notion of the feature registry in the feature store, which acts as a system of record for all of the data assets that are used across all AI models within the business, and also provides a single point of control for governance and for compliance related policy implementation. And then finally, a very important part of Tecton is the retrieval system. This is the system that powers serving of this context at any scale, at any latency, and any level of freshness, and very, very reliably, so that you can use your most important, you can trust this system for your most mission critical AI applications. So let's dig into how we're expanding this for the generative AI world. And let me bring Kevin right back in here.
Fantastic. Cool. So here are the 4 major capabilities that make it trivially easy to both provide, manage, and assemble the right context for your LLM application. Let's dive right in. With prompt management, you're now able to finally not just only manage features in Tecton anymore, but also prompts side by side. And of course, as a result of that, you get the exact same qualities that you're currently getting from Tecton to manage your features for prompts, like central standardization, the ability to discover and share your prompts, versioning, lineage, the ability to iteratively test what the right prompt is for a use case, etc. All with just one unified framework. And now, of course, prompt management by itself isn't the most amazing new capability, but we make it significantly more powerful by enabling you to enrich prompts with machine learning features. Because now Tecton is able to continuously update and is able to enrich your prompts with features which are continuously updated. That's what Mike talked about earlier in this presentation. That's been the bread and butter of Tecton for the last couple of years, where we automatically take care of all the data engineering, the plumbing, etc., to produce batch, streaming, and real-time features. And now, with managing your prompts in Tecton and using our prompt enrichment feature, with just a couple lines of code, you're able to have Tecton inject those features into your prompts to ultimately provide the most relevant, most important context to your LLM application in real time. But of course, real-time serving of prompt is only one important part of the equation. A lot of companies out there, they're also very interested in backtesting their prompts and fine-tuning their LLMs. And Tecton is able to generate historical point-in-time correct prompts to make that trivially easy. So let's take a quick look at an example of the good old travel assistant that Mike talked about earlier. We've got Alice, who is interacting with this travel assistant, and Tecton is enriching this prompt with a bunch of information about Alice. Like, what is she interested in? What are her preferred activities? How much budget does she have left? What's the time of day, etc. And now imagine that Alice is asking, okay, well, what are some activities that I may enjoy? And with the information from this enriched prompt, the LLM is now able to provide a personalized answer and suggest a little 100-mile bike ride to explore the vicinity of Paris on a pretty tight budget. Cool. So that's the power of enriched prompts. But of course, you don't always want to throw the whole kitchen sink of all the knowledge, of all the information that you have at your LLM. Because the more data that you inject into the prompt, the longer it'll take to process it, the more expensive it'll be. And also you run the risk that if you introduce irrelevant context, that your LLM's answers are actually worse. And as Mike mentioned earlier, with tools, agentic LLMs are able to decide, hey, what tools do I want to access in order to ultimately fetch the information that is most relevant for my use case. And Tecton is now making it easy to provide all of your features from your feature catalog to your agentic LLMs, which allows them to think and choose dynamically as they're processing questions and queries that are coming in, to choose what's the right feature, what's the right context that I may want to retrieve to best answer this question. So let's go back to Alice and the travel agent. In the next example here, we see that Tecton is now, of course, continues to inject information that is most likely always relevant and of fairly short length. But besides that, Tecton is now also making a tool catalog available to the agentic LLM. In this case, Tecton suggested to the LLM, hey, if you want, you can access any user's historical activities or historical restaurant visits. Fantastic. Now, question comes in again, hey, what activities in Paris may I enjoy today? And specifically, I want to try something new today. So of course, the LLM thinks, well, how should I know what this user has done beforehand? LLM's taking a look at the tool catalog and now asking Tecton to provide the historical activities of Alice. And then Tecton graciously responds to the request, feeds in those recent activities, which ultimately now allows the LLM to come up with a great suggestion for Alice to go for a cheap run along the Seine. Amazing. So that makes it trivial to bring features dynamically to your LLM. But oftentimes, you don't only want to provide features or really any structured, schematified data to your LLM. In many cases, you want to expose also knowledge to your LLMs, which could come from a variety of different unstructured data sources. So those are oftentimes large corpuses of text, like maybe it's your employee handbook, your budget policies, travel policies, your FAQ, whatever it may be. Then Tecton makes it easy to continuously ingest that unstructured data into your vector database and then expose any single one of these individual, many different knowledge databases as tools to your agent that, again, the agent can consider to use in order to best answer the question that's coming in. So let's take a look at our travel assistant. Alice is still looking for great activities. And in this case, what you now see is that the tool catalog expanded, because now Tecton is also making available the restaurant reviews by city knowledge base. And it explains to the LLM that this is a list of restaurant reviews. You can filter it by a city string and a budget range if you want to. Great. So Alice now goes ahead and asks, hey, what restaurants should I go to? I'm craving my French onion soup. Please help me out. LLM processes the query and decides, okay, I really want to now go to Tecton's restaurant reviews by city, filter the results down to Paris only, and then within those reviews, look specifically for anything that contains something that looks semantically like French onion soup. And besides that, I also really care about the historical restaurant visits. Tecton, again, complies with the request and makes just this data available, which the LLM can now process and ultimately come up with a great recommendation for Alice. Amazing. Let's recap how Tecton is making it easier for you to elevate your LLM applications with better context. We've talked about 4 capabilities: prompt management, which allows you to now manage your prompts in the same place as your features. You can combine the two by enriching your prompts with features to provide real-time, up-to-date information to your LLM. And then finally, we're making both features and knowledge available as tools that your agent can dynamically request on demand. So with that, let's hand it over to Sergio for a quick demo that shows you how to use all of that in action.
Thanks, Kevin. Could you stop sharing? Thank you. Let me share. Here we go. Okay, so hi, I'm Sergio Farragut. I'm a developer advocate here at Tecton. And I'm going to walk you through an example of what Kevin and Mike have been talking about. So in this scenario, we have a company that provides money transfer services through a mobile app called Transfer App. They currently have an FAQ that responds to, that has questions and answers for common questions about problems that users have. It's common for users to have problems with a transfer or to have their account suspended for some reason, and they use the FAQ to search for articles that are relevant to their current question. But the Transfer App team, the product team, wants something better. They want a chatbot using generative AI that takes that FAQ knowledge and responds to the customer needs in a better way. So they decided to build a RAG solution with generative AI for this purpose. And so in this demo, we'll walk through building a RAG solution with Tecton's new Gen AI package. And we'll build a RAG solution, and then we'll build an even better solution where we introduce personalization into it and show you how that improves the chatbot. So we're going to use Tecton's declarative framework to, like Mike and Kevin mentioned, to create prompts to load, set the FAQ data into the knowledge base, and to provide, in the personalized case, user features as tools to improve that personalization. And we'll also show how we use an agent service that is deployed into the Tecton platform and provides all of this functionality through an API. This company tries to decide to build this RAG chatbot solution, and they could go the naive way, right? They could say, okay, we need a vector database, we need an LLM, so we can sign up for those, and now we need to start building this. So they'll need to build all the embeddings, so they'll need to process the raw data for the FAQ, calculate the embeddings, load the database, the vector DB, and then create the interaction. So create the server with the question and answer API that users can use from within the app. That will need to take the question, process it into an embedding so that it can execute the similarity search, retrieve the FAQ entries that are interesting for that question, and then compose a prompt with the user's question and all of those candidate knowledge articles, push them out to the LLM and get a response. Now, while you can build this, there's a lot more to it when you want to put it in production. You'll need to worry about keeping the knowledge base up to date, for example. You'll need to worry about scaling this infrastructure, the server infrastructure that you're putting so that you can respond to large numbers of users. And you'll need to version all of this and keep this application functioning, do all the DevOps work to scale it as needed. And so that's a lot more work to get it really into production. So Tecton, we have a better way. There's a much simpler way of building this. We still see some of the same elements, but within the Tecton platform, we have the agent service, which I'll show you how to build in a second, that encapsulates the logic that you want the chatbot to have. It has the prompts that are needed to manage to provide the instructions to the LLM, and it provides access to the knowledge base as a tool, such that when the agent processes a user's question, it will build the prompt, it will pass the question, and as context, it'll pass the knowledge that is available, so the FAQ knowledge that we're going to build, that is available to the LLM to use as a tool. So it'll submit the prompt question in that context to the LLM, and then the LLM will decide based on the question whether it needs to use the tool to get some knowledge and retrieve that knowledge through the agent, do the similarity search, retrieve the relevant text, and finally submit that back to the LLM so the LLM can generate an appropriate response. So that's the first version of this that we're going to create, and then we'll go into a personalized version of it. So in this managed RAG chatbot case, we're going to create, like I said, a prompt that provides instructions. We're going to prepare the FAQ knowledge and deploy the agent service. So here's the prompt code. The prompt decorator tells the Tecton platform that this is an object that we want to manage. So this is the prompt management side that Kevin was referring to. So this prompt will become a managed set of code that defines a prompt. And here, what it returns is a set of instructions for the LLM. Preparing the FAQ knowledge is as simple as this line of code, right? Where we use the sources knowledge function within the GenAI package. We provided the source of data. This is a Parquet file with the questions and answers for the FAQ. You give it the vector database that you want to load to. In this example, we're loading it to a local vector database on my laptop, but this can be Pinecone or any vector database of your choosing. And finally, you pick which column to vectorize on. This is the column that we will automatically calculate embeddings on. So when you run this command, it will create a data pipeline that reads the Parquet data, calculates the embeddings using our optimized embeddings engine, and loads this data into the vector database. And as a result, we get this FAQ knowledge, which is a reference to this knowledge base. And now we can build the agent. So the agent service has a name. It's whatever name for the API endpoint that you want. It indicates which prompts it makes available. In this case, we're making available the prompt that we just defined. You can have more than one. And it provides the sets of knowledge that this agent will have access to. In this case, we've added the FAQ knowledge. Finally, we create a client to interact with that service. Let me go ahead and run this while I keep talking. And with that client, we'll be able to interact with this agent service and have access to both the prompts and the knowledge. So in order to build the chatbot, the Tecton Gen AI package includes a test tool that's a question and answer tool where you provide the client that has access to the service, you provide a model. In this case, we've instantiated an OpenAI GPT-4o model, and which prompt to use. And as simple as that, we've created a RAG application. So why is my account suspended? The common question for this kind of service. I don't know why I'm generating two responses there. This is the demo gods giving me a little grief, but it should only generate one. And you see how it generated the answer based on the FAQ, right? And it generates a good answer, right? It scanned the FAQ knowledge, found the questions that were similar to the user's question, and composed a response that makes sense for this question. Now, in this simple RAG example, there is no personalization, right? Whichever user is logged on to their app on the phone is not going to get a different experience based on who they are. Everybody, because we just provided general FAQ knowledge to the agent, but we can do even better. So here's what it looks like when we add personalization. So there's a few more elements here. Let me walk through this new architecture. Or expanded architecture. And we bring in the feature store. So we bring in what Mike was talking about, what Tecton's been known for many years now, which allows you to take raw data, whether it's streaming, batch, or real time, structured or unstructured, and it provides and automates the transformation and serving of those features, those embeddings, the prompts that we're talking about, and the domain knowledge that can be loaded into your integrated vector database, whichever one you choose. So we get vectorized data for domain-specific information, and we have features, including prompts and personalized prompts now, coming out of the feature platform and being delivered to the agent. We introduce this agent is now not only processing the questions and answers for the user, it also provides, as the session starts, it provides that personalized prompt where we have information about the user directly in the prompt. It provides the question, and it gives the LLM the context of all the tools that we're making available to it. So the domain knowledge and the features, the user-specific features that it can use to respond to questions. The LLM will reason the question and determine which tools it needs to use, retrieve data from the domain knowledge, doing the similarity search, or retrieve direct user features for different aspects of the user, like their profile or their transaction history, in order to respond to the user's question. So let's go build this one. So we're providing two different feature pipelines for this example. We've created a transfer stats pipeline that takes transfer activity and creates a couple of simple aggregations, the number of transfers in the last 7 days and the number of transfers in the last year. And it keeps us up to date. In the best instantiation, this is a streaming platform, a streaming pipeline that as the transactions are being processed, it's keeping these metrics up to date, and many other metrics that you could think of. The user profile is another example where we're providing the attributes of the user, the name, the age, and the current account status, which is also updated whenever the account status changes, whether the account is suspended or whether it's active. So now we're creating an agent that has access to the FAQ knowledge that we created before. We're building a contextualized prompt, which I'll show you in a second, and we're giving it access to these tools in order to improve the experience. So the prompt now is a bit different. You'll see that it has sources in it. This creates the data lineage. So this is one of the pipelines that we described, the user profile. Because it's a feature pipeline that exists on the platform, it already has lineage from raw sources to all of its transformations, and now to the prompt. So the prompt is also being managed for data lineage, and so it provides that full connection to the other pipelines it depends on in the platform. We've expanded the prompt a little bit. You see that we've incorporated some elements of the user profile into it, the name and the age of the user. We've asked it to address the user by name, and we've instructed it to use the transfer stats information to respond to the question if it needs to. The agent service is really just expanded. We're still giving it a prompt. We're giving it the new prompt. We're giving it the FAQ knowledge that we created before. And now we're giving it a couple of feature tools to access the transfer statistics and the user profile to better answer those questions. And again, we need the client. I should have hit run before I started talking, so give me a sec. So while that runs, I'll talk about, and let's get the Q&A running again. So again, now we have the client that we just created, the same OpenAI LLM that we're using, the new prompt, and we're providing context. This is where we identify the user. This is where the mobile app, the transfer app, has the user is already logged on to their app on their phone, so the user is identified. So it provides this information to the API and can therefore access user-specific information. So let's try the question again. Why is my account suspended? And you'll see that I'll change the user here in a second so you see the personalization. User one, his name is Jim, so you see is addressing the user by name and is telling him specifically why his account might be suspended. Because of unusual activity in the last 7 days, you made 20 transfers, which is very high compared to 22 transfers in the last year. So this could have triggered a suspension. And a little more information that comes from the FAQ on why you may get suspended. And if you believe this is a mistake, contact support. So this is, let me now show you when I change users, so you see the personalization by user. So I'm going to use user 2 now. User 2 is, let's ask the same question. Why is my account suspended? So in the case of user 2, her name is Mary, and her account is actually not suspended. Her account is active. So you'll see in the response that because the LLM has this information, it has the ability to determine specifics. So she's saying that her account may be suspended. So this is information from the FAQ, which is it's also considering the age here. And I'd forgotten about this. So since you're 16, the reason for the suspension is that if you initiating a transfer when you're less than 18 causes a suspension. So that may be the reason for her. But if she asks, so if Mary asks, is my account suspended? It'll use the appropriate tool to figure out whether Mary's account is suspended. So it says your account is currently active, not suspended. So you see how we can drive personalization with this. So this is the examples I had for you, and you can see that by adding more tools, maybe Mary had a problem with her transfer, right? And she wants to know specifically, why did my transfer not occur? We haven't given the LLM information about individual transfer failures, but we could easily add a pipeline that has that information and enable the LLM to answer that question. So with that, let me just talk a little bit about what happens after. So this is a notebook where I've been, iterating on the prompts, and it's really easy to iterate on the prompts and develop and change the behavior of the chatbot very easily and test out really fast. But once you're done, once you have something that you're happy with, you can easily productionize it by just running a command line Tecton apply. So Tecton apply will deploy all of the feature views that it needs. It deploys the prompts, it deploys the knowledge base, it deploys the agent services, and creates those, makes those endpoints for the API available for access through authentication and providing the inputs it needs, like the real-time inputs, if you've defined real-time inputs for it. Like, for example, location of the user might be useful in some scenarios. So this is an example of what the Tecton Apply looks like. You see here that it's creating some different pipelines. It's creating some feature services to serve the functionality that we just defined with just a few lines of code. One more thing that I'd point out is if we go through this particular example and we go back here, we can see what happened, right? It asked, the user asked, why is my account suspended? The LLM asked for account suspension FAQ information. It took that information into account. It then asked for the transfer activity to figure out that this user's account would have been suspended due to that kind of erratic activity in their transfers, and therefore it was able to provide a response. So with that, I will conclude that with Tecton, as you can see, and its declarative framework, it's really easy to do prompt engineering, to manage the prompts, do A/B testing, add sets of knowledge, add sets of tools, and really create a personalized or a customized generative AI application. And there's a bunch of stuff that you don't need to do, right? The Tecton platform takes care of putting it into production by automating all of the data engineering, the versioning, provide data lineage and the input analysis that enables, providing governance, as Mike mentioned, the orchestration of the compute, scheduling of the jobs, monitoring of everything. So you can just focus on building the generative AI logic you need and giving it the information it needs in order to do that. And Tecton takes care of all that other hard work. So with that, I'll send it back to Mike and Kevin. And
nice job, Sergio. I thank you. Okay, so I just wanted to, coming up on the hour, I just wanted to close out with one other thing here. We've talked about a lot of stuff, how Tecton is adding a bunch of new capabilities to strengthen the core of the platform and specifically be useful for a lot more useful for predictive ML use cases, but also we've added a lot of stuff to add support from a centralized platform to generative AI use cases. So now we have a central platform that can plug into and integrate with any data sources and be the central command plane, source of truth, system of record for all of the data assets that flow into any AI application across the business. And the whole point of this is to help you go faster, get to production faster, help you build better models that are smarter, and help you do it with lower cost. And so the last thing I just wanted to mention here is you can go test out a lot of this stuff right now. You can go poke around in the UI, see some existing example applications, or you can actually build some stuff on your own. Just go to tecton.ai/explore and you can get started. Also, if you're already a Tecton customer, just talk to the Tecton team members that you know, and we'd be happy to show you more about any of this stuff. And if not, get in touch and we'd love to chat with you. So I thought it would be also good to just close out with a video from one of our other customers, Josh from Atlassian, who's been on the ML and AI team at Atlassian for many, many years now. And let's go to him and we can outro with that. So thank you so much for joining us. This has been great. And please get in touch if you have any questions or you think this might be useful for you.
My name's Joshua Hansen. I've been at Atlassian for 11 years. I joined as a grad in 2013, and these days I'm the principal engineer on Atlassian's ML platform team. When you search for something in Jira or Confluence, there's going to be some amount of machine learning going on in the background to show you the most relevant things to you. I think with ML, the quality of the end product is mostly a function of how many times you're able to iterate on it and get to these incremental improvements. So it's really important that we get that cycle time as fast as possible. One of the big challenges we had with it was just the workflow around creating new features was really heavyweight, sort of burdensome, and required, sometimes like weeks of effort from an engineer working on that. When really the people who are kind of driving the creation of those features are sort of data scientists and machine learning engineers who are not necessarily experts in data pipelines and things like that. Might be working with a data scientist and they would sort of define what they thought the feature should be in say a Databricks notebook. And then we would basically take that notebook and figure out how to put it into our system and actually materialize the feature and serve it. Our first sort of attempts at feature engineering took months, like 3 months. And yeah, these days it's quite viable to build a feature within 1 day with Tecton. Tecton is a game changer for the workflow and sort of the efficiency with which we're able to develop and deploy features. And I think for us to have built something comparable to it would have been a huge amount of effort and investment for us. It's allowing you to define these features in this really user-friendly way. It's allowing you to get those to production in a really efficient workflow. It's handling monitoring, it's handling online, offline consistency, and all these things that are not really like obvious initially when you first start sort of building these kinds of things, but the gluing it all together, making that all work really coherently in this single package is what's been really valuable.